Welcome to the second part of What's New in Autodesk Inventor 2018, a deep dive into new functionality. This is Andreas Ernst Wagner and I'm working as a designated support specialist at Autodesk. I'd like to continue the What's New for Inventor 2018 with the port design enhancements. With Inventor 2018, the model-based definition has been introduced. Model-based definition is a powerful new set of tools for adding annotations, geometric dimensioning and tolerancing, and other manufacturing information directly to a 3D part. You can also export the model-based definitions into Step 242 and a 3D PDF. In the following slides, I only give you a small overview of how you can access the model-based definition environment, how it looks like while you are working with, and where you can get a deeper start into this topic. Let's start with how you can get access to the model-based definition environment. Once you've entered an IPT, you should look for the Annotate tab. On that tab, you find all necessary commands to add manufacturing information to your model. A good start point is the tolerance feature command. With this command, you can apply GD&T annotations, feature control frames, and datum identifiers. You should also enable the Tolerance Advisor browser to check the health of your tolerance scheme. The Tolerance Advisor lists potentially problematic datums and datum reference frames, information about which features are not fully controlled, and errors in a tolerance feature. Just an aside, you'll take some time to understand how the Tolerance Advisor works, especially for European GD&T standards. Keep your annotations simple at the beginning and you'll learn quite fast. So, away from the theory and start with the demo video.
More and more manufacturers are implementing the use of rapid prototyping and CNC into their workflows. And as a result, communication of design intent and specifications through your 3D model is more critical than ever. New model-based definition tools in Autodesk Inventor 2018 allow you to add geometric dimensioning and tolerancing annotation, or GD&T, and other manufacturing information directly to your 3D model, meaning that you no longer need to wait until both the 3D model and the 2D documentation is complete before beginning the process of prototyping or even manufacturing your designs. Instead, annotations are added to the model to describe the tolerances, controls, and allowable variations in the model, resulting in a fully defined 3D model. To reduce errors, Inventor 2018 adds a Tolerance Advisor tool within the 3D modeling environment to help identify and resolve common problems related to your tolerancing scheme. The visibility and scale of 3D annotation can be set through design views, giving users control over how and when 3D annotation is displayed. Once 3D annotation has been added and verified, the model can then be exported to a 3D PDF for enhanced collaboration. All annotation is visible in the 3D PDF, and when the annotation is selected, you can see what surfaces are included. Annotation data can also be exported to a STEP AP242 file. This industry standard protocol used during export allows this information to be utilized downstream in other manufacturing processes. This gives manufacturers a more complete three-dimensional model. And when you're ready to document your model in two-dimensional drawings, model-based definition annotation can easily be retrieved and placed onto your 2D drawing views without the need to recreate them. Model-based definition tools in Autodesk Inventor 2018 streamline communication between engineering and manufacturing by directly integrating design intent into your 3D models.
If you'd like to dig into model-based definition, I recommend a great Autodesk University class from Peter de Strijker about model-based definition at Industry 4.0. I've also watched this class and was thrilled about the content. Another good resource to get knowledge about model-based definition is the Autodesk Knowledge Network. Once you're on the AKN page, you can select your product of choice in the search field. Then search for model-based definition and you'll get a lot of suggestions you can follow. On the left side, next to your search results, you can also filter for specific sources like the Inventor Help or Autodesk University. I think you'll find enough information about MBD for sure. In the Inventor 2018.1 update, you get delivered support for modifiers like free state, projected tolerance zone, statistical, etc. Even an annotation scale control is added in the sheet metal flat pattern. We also made the support for 3D annotations available when you export a DWF file. Simply use the Export to DWF command, which is added to the Export panel now. This enhancement comes along with the Inventor 2018.2 update. Yes, this enhancement coming with the Inventor 2018.1 update is one of my personal highlights. On the Sketch tab inside the Application options, you have now the Project Object as Construction Geometry checkbox available. If this checkbox is enabled, all projected geometry in a sketch is set to construction line type. In previous versions, you still need either before select the construction line type or you assign this line type after you've created projected geometry. Previously, when you added dimensions or constraints to sketch geometry with a work axis or work point, you had to use the project geometry command at first to project the selected work axis or work point. Now, when you select an axis or point you are dimensioning or constraining, the selected work axis or work point is automatically projected when you add dimensions or constraints. Another personal highlight of mine, maybe for you as well. In the past, you couldn't have a sketch profile is located on e.g. an origin plane, but the intended extrusion should start, for example, 20 mm beyond the sketch profile and end another 50 mm from its start. To achieve that requirement, you needed multiple additional work planes. With the new distance from face option, you only need to select A, the sketch profile, and B, the surface or work plane where the extrusion should start from. In conjunction with the distance from face option, the More tab offers different results depending on your geometric extrude inputs. If you have such particular use cases, I recommend to toggle through the alternate solutions until you get the required result. In Inventor, I've got the sketch containing multiple profiles and is located on the XY origin plane. The intention is to use only one sketch for multiple extrusions starting on different heights. The one and only additional work plane I'm going to use is 5 mm beyond the origin plane. In the first step, I create a common extrusion from the circle profile from my base body. I hope all of you know that you can directly assign parameter names during the value input in the dialog box. The syntax must always be parameter name equals and then the value. I use the height value for the cylinder height. I reuse the sketch and start again a new extrusion for a slot. Now I use the new distance from face option and select the existing 5 mm high work plane. The value input is cylinder height minus work plane height. The parametric formula leads to that my slot always ends on the top of my first extrusion, independently how long the body is. In the last step I reuse the identical sketch, however with a different profile constellation. This extrusion shall start from the top of the cylinder face. Choose again the distance from face option and just select the called cylinder face. As you can see, Inventor automatically detects the select to terminate feature by exiting the face option and lets the extrusion start on the intended model face. When you think about the effort to achieve the same result in previous versions, you get a quite efficient workflow provided now. After this excessive extrusion battle, something is more lightweighted. You can now create a symmetric hole type that creates holes in two directions. The flip termination button, still available in Inventor 2017, is replaced by direction 1 and direction 2 buttons. For spot face holes, you can now specify 0 as a value for the bore depth. As a result, you can now place a spot face hole on the termination face of a body. Might be you had such kind of models where you have holes that are overlapping other model geometry like a fillet. Unfortunately, those geometry remained with a certain fragment and the hole wasn't properly created. You had then be creative to remove the fillet piece somehow. You can now use the new Extend Start checkbox to overcome described situations. The purpose of Extend Start is to remove a fragment resulting from the creation of the whole impacts bordering geometry. You can now create a chamfer that does not require an entire edge. The new Partial tab is added to the Chamfer dialog box to support the creation of partial chamfers. The setting on the Partial tab allow you to terminate a chamfer at a specific distance along an edge. You create a partial chamfer by defining the location of end vertices along an existing chamfer edge, and the start vertex is created automatically. Alright, to provide clarity of this enhancement, I need to go back to Inventor 2013. In that version, we've introduced to set a sketch scale by the first dimension. In other words, the first dimension in the first part sketch determines the scale of the sketch. The limitation you had: after you place the second dimension, edits of the first dimension no longer change the sketch scale. The newly added application option, Autoscale Sketch Geometry on Initial Dimension, is applied on sketches follow after the first sketch of a part model as well. Further, the checkbox should be seen as general option to switch off or on the autoscaling and function as addition to the behavior of the Inventor 2013 enhancement. So at the end of the part design enhancement, a small outro. There is a new visibility icon on the 2D sketch mini-toolbar, allows you to switch on or off the visibility of the sketch as consumed of the feature where you selected a face.